welcome to Genique. Our next topic is the coordinate systems. Previously, we have discussed the Maxwell's equations and the importance of the significance of the equations. Okay, so what is del cross E equals to 0? What is closed integral E dot dl is equals to 0? And what is del cross H? And what is del dot B is equals to 0? And what is del cross E equals to 0? Okay, already we know the first and the fourth Maxwell's equations. Okay, they are collected from the Ampere's law and the Gauss law, and the second and third equations are somewhat different. Okay, so by using the Stokes and the Gauss divergence theorem, we proved those equations also. Okay, so now, and one more important concept here, it is the coordinate systems. Here we will discuss some of the important topics only for the coordinate system. Here the coordinate systems are very important in solving the problems. If you don't know the coordinate systems, means you no need to study the subject. So that's why you have to concentrate on the coordinate systems. Okay, here we will discuss mainly three coordinate systems here. The first one is Cartesian coordinate system. Second one is a circular cylindrical coordinate system, and the third one is a spherical coordinate system. Okay, there are three main types of the coordinate systems are there. So what is this coordinate system? Why we use this coordinate system? So we use the coordinate system to locate a point in the space. To locate a point in the space. Suppose if you want to specify any point in the space, we have to use this coordinate systems. Okay, so there are mainly these three types of coordinate system. Suppose if you take the Cartesian coordinate system, okay, and cylindrical coordinate system and spherical coordinate system. Okay, so what are the parameters here? The parameters here are what are the parameters? Here the parameters are x, okay, the parameters and the unit vectors. The parameters and the unit vectors. Okay. So what are the parameters and the unit vectors of this three coordinate systems? Here the Cartesian coordinates will be having the parameters x, y, z. These are also called as the coordinates. Okay. So what are the coordinates in this? Rho, phi, z. Rho, phi, z. So here what are the coordinates here? R, theta, phi. Okay. These are r, theta, phi. So this is the Cartesian coordinate system. It is also called as the rectangular coordinate system. Okay. So this is cylindrical coordinate system. It is a spherical coordinate system. Okay. So what are the unit vectors? The unit vectors along x is ax, along y is ay, along z is az. Okay, the unit vectors along rho is a rho, a phi, az. These are the unit vectors. This is ar, a theta, and a phi. These are the unit vectors. So okay, so see, if you want to specify any point in the space, there must be some reference. Okay, suppose if you want to specify any point in the space, suppose Suppose if the point A is 5 kilometers. 5 kilometers means from where it is 5 kilometers? From the origin or from any point or from any bus stand or from any tree, like that. So we have to use some kind of reference. So by using a reference only we can find the distance. Okay, by using the reference only we can specify the coordinates. Okay, so there must be some reference. So we, by using the, see what is the coordinate system? To locate any point in the space with respect to any known reference. Okay, the reference must be known. Okay, suppose what is the reference here? Suppose if you come to the when we use the Cartesian coordinate system, when we use the cylindrical coordinate system, when we use the spherical coordinate system. So there must be the known reference. What is the known reference? The known reference must be, it is the known reference. Okay, the known reference must be xy plane or yz plane or xz plane. 3 infinite planes. Okay, if you know the 3 infinite planes, automatically you can represent any point x, y, z in the Cartesian coordinate system. So x means what? The x, y, z can be specified with respect to any of these 3 planes. Okay, so by using with respect to these planes where the point is existing, it is called as the Cartesian coordinate system. Suppose if you come to the cylindrical coordinate system, when we have to use the cylindrical coordinate system means if you know the reference as what? If the reference as infinite line z axis. If you know the reference, if there is any infinite line z axis, okay, as the reference, then we go for the cylindrical coordinate system. The cylindrical coordinates are specified with respect to any imaginary axis or the reference line z axis. Okay, now if you come to the spherical coordinates, when we have to use the spherical coordinate system, these r, theta, phi are calculated with respect to the, with reference to the origin, with reference to the origin or any point, any known point. Okay, so where we have to use this Cartesian coordinate system, cylindrical coordinate system or spherical coordinate system means if you know the 3 infinite planes xy and yz and zx, so we can specify any point by using the Cartesian coordinate system. If there is only the z-axis as the reference, so it is simple to use the cylindrical coordinate system. If there is any point origin or any known point as the reference, then it is better to use the spherical coordinate system. Okay, see, if you observe this is x, y, z. These x, y, z are all are what? These are all are distances. These all are distances. If you come here, this is what? It is a distance. It is also distance. What about this? This is an angle. Okay. If you come to here, what is this? It is the radius of the sphere. Okay. It is the radius of the cylinder. Okay. It is, we will say what is z. Okay. It is also distance. It is angle. It is angle. So one thumb rule here is, if all the 3 coordinates are the distances, then this is a Cartesian coordinate system. Suppose any point is given. Okay. 3 coordinate points are given. So how to distinguish whether it is given in the cylindrical coordinate system or spherical coordinates or Cartesian coordinates? Okay. So to know that, we have to know that what is x, y, z. These all are distances. What is rho, phi, z? Rho, phi, z is, it is a distance, it is an angle and it is a distance. Okay. So here there are 2 distances, 1 angle. Okay. If you come here, this is one distance, two angles. This is theta is an angle, phi is also an angle. Okay, suppose if any point phi pi by 2 comma 0 degrees are given, pi by 2 degrees or pi by 2 radians or 0 degrees are given. 0 degrees are given. So what about this? 0 degrees are given. What about this? It is a distance. It is radians. It is an angle. It is an angle. So which kind of coordinate system it is? These are the spherical coordinates. There are two angles. Suppose if any coordinate system it is given like this. So that means these all are the distances. Okay, these all are the distances. That means this is the Cartesian coordinates. Okay, suppose if any thing given like this, this is two distances and one angle, and this is what? The cylindrical coordinate systems. So like this you have to identify in which coordinate system it is given. Suppose in the given expressions, if there are rho phi z components are existing, that belongs to the cylindrical coordinate system. If in the expression, if there are r theta phi components are existing, then that is the spherical coordinate system. If the expression is given in the x, y, z, then that is the Cartesian coordinate system. Okay, now so what is suppose if you come to the coordinate system, Cartesian coordinate system. So what are the parameters here? Here x, y and z. These are the three parameters. Then what is x, y, z? So how the Cartesian coordinate system is specified in the space? Suppose how the Cartesian coordinates? There are three infinite planes like this. Let us suppose if it is x, it must be y and it must be z. And some people will write this one as what? You can also specify like this, but we will represent the plane like this. Okay, you can also specify like this, or you can also specify like this. Okay, this is x axis, y axis and z axis. Okay, x axis, y axis, z axis. If it is positive x axis, then it is the negative x axis, it is the negative y axis, it is the positive z axis, into the board negative z axis. Understand? Now see, this is the Cartesian coordinate system. See, observe this. If it is x, this must be y and it must be z. X, y, z. You have to follow this right-handedness. You have to follow this right-handedness. Observe this. So now, so this is the Cartesian coordinate system. Suppose if you take one more example, suppose if this one is y and what it must be? It must be z and what it must be? If it is y, it is z and this must be x and this must be x. Okay, this is the x axis. Okay, suppose if you take this one as z and what about this? This must be y and this must be this must be x and this must be what? Y. Understand? Z, x, y. So always it is like this. It has to follow the right-handedness. Okay, it is x, y, z. It is y, Z, X, and it must be Z, X, Y. Okay, so always this will be what? X, Y, Z. Okay, this is what? After X, you must follow Y, and after that it has to come X. So X, Y, Z, and Y, Z, X, and Z, X, Y, like this. Okay, suppose if I specify in terms of the cylindrical coordinate system, what is the cylindrical coordinate system? Rho, phi, Z. If you observe this, rho, phi, Z. What are the spherical coordinate system? R, theta, phi. Okay, R, theta, phi. You have to know that. I forgot to tell you this. See, I forgot to tell you this. Observe this. It is X, Y, Z. These are the coordinates. These are the rho, phi, Z. These are the spherical cylindrical coordinates. These are the spherical coordinates. Okay, you have to notice that the Z in the Cartesian coordinate system is same as the Z in the cylindrical coordinate system, and the phi in the cylindrical coordinate system is same as the phi in the spherical coordinate system. Always it has to follow, after rho we have to follow phi, after phi it is Z. It has to follow the right handedness. Okay, like this. Understand? So you have to follow these axes after A rho, A phi, AZ, like that. Okay. So we have to follow this right handedness. After X there must be Y, and after Z, after Y it must be Z, and after Z it must be X. Okay. And one more important thing here is orthogonality. Okay, we will see what is orthogonality next. Okay, orthogonality and orthonormality. So these are the things we have to observe. Always we have to follow this right handedness. Okay, we have to follow this sequence while writing the coordinates or the unit vectors. Observe this. What is X here? What is X here? X is nothing but, it is X axis. This is representing what? X is equals to 0, and this is X equals to 1, X equals to 2, X equals to 3, like this. 1, 2, 3. Okay, so what is X equals to 3? This entire portion up to infinity, this entire portion up to minus infinity is representing what? Is representing what? X equals to 3 plane. X equals to 3 plane. See, this entire means it is X axis, means it is from minus infinity, it is from minus infinity to plus infinity. It is a sheet. Okay, what is the X coordinate? We know, already we have studied. Okay, X equals to 3 represents, it's a plane. It's a plane of what? It's a plane of what? Parallel to YZ plane. It is parallel to what? YZ plane. It is the YZ plane. Okay, so X equals to 3 is the plane. Okay, so now what is this X equals to 3? What is this X equals to 3 is the coordinate. So what is the coordinate X? X is nothing but, it is the shortest distance from, what is this? YZ plane. So it is the distance from here to here, right? From here to here, it is the shortest distance from the YZ plane. It is the shortest distance from the YZ plane, right? Now, or it is also called as the perpendicular distance from the YZ plane at any point. Now, what is Y? What is Y axis? What is Y coordinate? let us suppose this is y equals to 5. What is the y equals to 5? This entire portion representing the y equals to 5 line, right? So this is y equals to 5 means it will be outward and inward. This is the plane. This entire portion is representing the y equals to 5 line. So this is, let us suppose this is a plane, y equals to 5. Okay. So this is y equals to 5 is a plane parallel to what? It's a parallel to xz plane. It is parallel to xz plane. Okay, so how can I write this y coordinate? So it is the shortest distance from the xz plane. So I can write the shortest distance from, what is y as? It is the shortest distance from xz plane. I am writing this dash as it's nothing but it's a plane. Okay, so what is z? Z is nothing but, let us suppose z is equals to some 4. Z equals to 4 means it is 0, 1, 2, 3, 4. Okay, so z equals to 4 representing this entire portion representing the z equals to 4. Okay, this is z equals to 4. Okay, so it is parallel to what? It is parallel, it is a plane. Actually z equals to 4 is a infinite sheet, or it is a plane. It is parallel to what? It is parallel to xy plane. It is parallel to xy plane. So it is the distance from the xy plane. It is distance from the xy plane. Okay. It is the shortest distance. Shortest distance from the xy plane. Now, so this is nothing but x, y and z coordinates. Suppose if you want to know the x equals to 3 and y equals to 4. X equals to 3 and y equals to 4 means what? Suppose if you want to represent x equals to 3 and y equals to 4 and z is equals to 0. How can I write? What is z equals to 0? Z equals to 0 represents the xy plane first. So on this board, I have to represent x equals to 3 and y equals to 4. Already it is there, x equals to 3 means on this line, on this plane, and y equals to 4. Y equals to 4 means this is y equals to, this is y axis, right? Y equals 0, 1, 2, 3, 4. Let us suppose 1, 2, 3, 4. Okay. Let us suppose this is the 4. 1, 2, 3. If it is 4, then this will be the point. So what is x? X coordinate is, it is x coordinate. This is 3, 4, 0. It is the representation of this point. Okay. So 3 means it is the shortest distance from the YZ plane. It is 3. What is 4? 4 means it is the distance from here to here. Means it is the shortest distance from the, what is this? It is the Z and it is X, XZ plane. Y coordinate is shortest distance from the XZ plane. Suppose it is 0. It is 0 means it is on the XY plane only. Suppose if it is given, Z is given as 5 means, and it is given like this, and suppose if the Z is given as 5 means what it can. So it will be, the point will be here only, but it is 5 units out of the board. Okay. So this is the representation of the Cartesian coordinate system. Okay. Now, so what are the unit vectors of these kind of, for this Cartesian coordinate systems? So what is the unit vectors of the Cartesian coordinate system? So what is AX? What is unit vector? So to know the unit vectors, first of all you have to know what is unit vector definition. Okay. What is unit vector? So unit vector is a vector. It has the magnitude 1 and it has the direction in which the parameter increases. Okay. Unit vector is the vector magnitude magnitude 1 or unit magnitude with the direction in which the parameter increases. The parameter increases. Okay, so this is the unit vector. So it is having the unit magnitude and it is increasing in the direction of the parameter increases. Okay, suppose if I want to write the unit vector ax, so it will be having what is the magnitude? This will be having the magnitude is equals to 1. What is the direction? The direction is equals to, in which, what is the parameter? Here the parameter is x. The direction in which the x increases. The parameter in which the x increases. Okay, so that means what? Suppose if I want to write the parameter, if you want to write the unit vector ax, okay, what is the direction of this unit vector in which the parameter increases? See, observe this. This is x equals to 0, x equals to 1, x equals to 2, x equals to 3, x equals to 4, x equals to 5. So in this direction x is increasing. In this direction x is increasing. So that's why, what is the ax direction? The direction, the unit vector will be having in this direction. You have to note this. Okay. So this is the unit vector direction. Okay. Always unit vector will be in the direction of the parameter increases. Okay. Suppose if I want to write the ay, the direction of ay, how the ay will be? How can I specify ay? The ay will be in the direction. It will be having the magnitude 1. What is the direction? The direction will be in which the y increases. What is the direction of y increasing? This is the direction of y increasing. So it is ay direction. It is the direction of ay. Okay. So what is az? Az means it has the magnitude 1 and it has the direction in what? In which the parameter, the z increases. So it is the direction in which the z is increasing. Okay. So this is az. Understand? So these are called as the unit vectors of this Cartesian coordinate system. Ax, ay, az. If it is ax, what about this direction? This will be minus ay. If it is ax, it will be minus ay. If it is az, it will be minus az. Okay. So this is x parameter increasing direction. It is the parameter decreasing direction. Okay. So these are the unit vectors. See, if you observe this, what about this? It is x equals to plane, x equals to 3 is equals to plane means what? You can assume it is as a sheet coming out of the board and into the board. Okay, so you can represent this one as a sheet. Okay, so this is one sheet and this is one sheet and this is one sheet. Okay, so that means it is sheet means what? It is one surface. Okay, so what is the surface direction? The surface direction is nothing but what? This is x equals to 3 is a constant. X equals to 3 is a constant surface, right? X equals to 3 is a constant surface. So this is surface and this surface has the direction in which? What is the direction? This surface can move this direction or this direction. Understand? Why? Because see, this is a surface. The surface always will be moving normal to the surface. Okay. So to understand this, so observe this entire board. Okay. Let us assume this entire board as one infinite sheet. Okay. Let us suppose this entire board as one infinite sheet. Okay, let us suppose these are the boundaries. These are the boundaries. Okay, this is one surface. Okay, now if it is an infinite sheet, okay, is there any chance for this surface to move upward or downward, or rightward or leftward? There is no chance, because these are the boundaries. I'm taking as an ideal example. Okay, so this surface cannot move upward direction, rightward direction, rightward, leftward, downward. Okay, because these all are fixed boundaries. Okay, so this entire infinite sheet of board can move only either in this direction or in this direction. Understand? So that means how this entire surface is moving. This entire surface is moving in this direction. Means out of this board direction. So the surface can move this direction or this direction. So that means always the surface will move normal to the surface. The surface direction will be always normal to the surface. So this is the normal direction. In the similar way, observe this. This is x equals to 3 is an infinite sheet. X equals to 3 is a constant plane is an infinite sheet. And this can move, and this surface, this infinite sheet can move either this direction or this direction. There is no chance of moving this direction. Okay? So that is the thing. So what we can write? If x equals to any constant plane can move normal to the surface. Okay? You have to note that point. Suppose if you take x equals to constant surface, okay, if you take any x equals to constant surface, then the surface direction will be normal to the surface. What is the normal to the surface? If it is a sheet, what is the normal to the surface? What is the normal to this surface? It will be in this direction. Okay? Normal to the surface is, that is what? Ax direction. Suppose if you take y is equals to constant surface, then what is the surface direction? The surface direction is equals to ay direction. Suppose if you take z equals to constant surface, then the surface direction will be az direction. Okay, always the surface moves normal to that surface. Okay, so these are the unit vectors of the coordinate system ax, ay, az. First of all, to understand the concept of unit vector, you have to know the definition. What is the definition? The vector with unit magnitude with the direction in which the parameter increases. Okay, so these are the unit vectors of the Cartesian coordinate system. Okay, next, so we defined what is x, what is y, what is z, and also we defined the unit vectors of each and every parameter. Okay, so now what are the ranges of this x, y, z? So what is the range of this x, y, z? This is a positive x direction and this will be the negative x direction. So that means the range can be minus infinity to plus infinity, because it is a distance. Okay, it may be from minus infinity to plus infinity. So what is the distance? What is the range? Minus infinity to plus infinity. Here also the range is minus infinity to plus infinity, because I can extend this up to minus infinity, I can extend this up to minus infinity, I can extend this up to plus infinity, into the board minus infinity. So these are the three ranges for these three coordinates x, y and z. The range will be, if the distance means, see, the range will be minus infinity from minus infinity to plus infinity. Now, one more important thing is, write a note. Every coordinate system is orthogonal and orthonormal right-handed system. Orthogonal and orthonormal right-handed system. What is the meaning of this orthogonal and orthonormal system? Means, suppose orthogonal means the dot product of any two different unit vectors of the same coordinate system is 0. Okay, the dot product of the any two different unit vectors of the same coordinate system is 0. So this is, what is the orthogonality? The dot product of the any two different unit vectors of the same coordinate system is 0. Okay, so this is the orthogonal property of the unit vectors. Okay, so that means the ax dot ay dot az dot ax, you cannot write ax dot a rho like that. Okay, so that means the dot product of any two different unit vectors of the same coordinate system. Suppose if you are taking the dot product of any two unit vectors and that is 0, means the two unit vectors must be from the same coordinate system. Okay, you cannot write ax dot a rho, ax dot a phi like that, ax dot ar like that. Okay, now what is orthonormal property? What is orthonormal property? Orthonormal property is that the cross product of the two different unit vectors of the same coordinate system is giving the third unit vector in the by following the right handedness. Okay, that means what? Ax cross ay cross az and az cross ax is equals to ax cross ay, the next xy, after that it will be z, after y z, and it will be x, zx, it will be y. If there is any shuffle in these two, automatically the minus n will come. That means, suppose if there is ax cross az is there, then I can write the third unit vector, but it is not following the order, the predefined order. So after x there must be y, then there will be z, but here we are getting az here, we have to put a minus here. Okay, like that. So we have to take this same thing can be applicable for the remaining coordinate systems also. Okay, so like that. So like that, what? A rho dot a phi is equals to az, a phi dot az is equals to, sorry, a rho cross a phi is equals to az, a phi cross az is equals to a rho, then az cross a rho is equals to a phi. And for the cylindrical coordinate system, ar cross a theta is equals to a phi, a theta cross a phi is equals to ar, and a phi cross ar is equals to a theta. So this is the right handedness of the the unit vectors, and this is called as the orthogonal property of the coordinate systems. Okay, thank you.